Hi everybody! In this video, I'm going to present our recent work on GitHub Copilot as an AI pair programmer. As you may already heard about Copilot, like after OpenAI announced the codex, that was like an explosion in software community, and like all people are trying to work with Copilot, which is actually a tool based on this codex model, and it's based on GPT-3 language model, which is pre-trained on a huge number of line of code and repositories from GitHub and all over the internet. And you can use Copilot as an extension on Visual Studio or even like other IDEs. There are like lots of studies that talking about how, for example, we can use Copilot to solve a problem correctly, or how, for example, we can use Copilot as an AI pair programmer to complete a programming task. But in this study, we wanted to kind of open the door to this question that what is going to be and how is going to be the quality of the codes in our softwares and open sources in future when they are going to be half written by these tools such as Copilot. So as the title of our study said, we are going to see like using Copilot as an AI pair programmer is going to be an asset for software projects or a liability. So I'm going to briefly tell you that how Copilot works, so you may already know. You can like a description of a problem that it's called prompt, and based on that, Copilot can generate some code for you within the IDE. The prompt is not necessarily should be like a natural language description. It could be even a block of code. Copilot also suggests you a top 10 solution per each prompt. You can like try to see like other suggestion for the same problems up to top 10 with Copilot. In this study, for answering actually to partially answering to that questions, we designed two different parts for our study. In the first part, we dig into fundamental algorithmic problems such as like sorting BST and graphs, and which are very essential for assessing the programming skills of someone. Even, for example, for developers before joining a project, they will be assessed on such fundamental algorithmic problems. And in the other part of the study, we try to compare Copilot with human to see how its code are competitive with human in different aspects. So for the first part of the study, we collect our programming task from this famous well-known book, which is Algorithm Design. And we collect 20 tasks from this book in different categories such as sorting algorithm, BST, graphs, and greedy algorithms. But because the problem descriptions in these papers are sometimes pages, so we need kind of prompt engineering here, because when the description of the problems that we are giving to Copilot is very long and with lots of like details, it may confuse it to generate or even it may confuse it to even be responsive to that description. So that was a reason that authors of this study, me and my colleagues, collect problems from this book and kind of summarize that description. However, the description for this problem could be easily like found in the internet or in different websites, but we wanted the description to be human written and handwritten to kind of avoid the memorization risk in Copilot, like memorize the exact text from its trained data set and return back as the solution. We summarize the problem, we check if they're correct, understandable by human, and the third author who lectured this course several semesters at university try to resolve the conflict and also check the descriptions. We end up with 95% kappa agreement on the descriptions that are complete and understandable and summarized. So then we fit these problems descriptions to Copilot, and Copilot generate code for us for those problems. And Copilot was responsive 87% of the time to the problems descriptions that we generated. Since in this part of the study we kind of like to look into the reproducibility of the, like for example, if I ask Copilot same problem today and like after 10 days, is it going to be still able to generate the correct solution for me or not? However, we don't know like what's happening behind the curtain of like Copilot. We don't know like where our query is going to be run, in which model, if there are different versions or not, and we cannot like check the logs of the model, but we want to, and with also by considering all the uncertainty of this large language models, we wanted to see that how it can reproduce those those solutions. So that was the reason that we designed our study in 2 trials. In each trial, we try each query or each problem description 3 times and collect the responses to evaluate, to actually conduct our evaluation. So this is a summary of our result in different algorithm problems. If you wanted to like know more details about each algorithmic problem, you can check our paper. Like the result with details are already within the paper. But I kind of try to summarize them here. And the solution that we collect from Copilot for this 20 task shows that Copilot cannot find the correct solution for almost 50% of the problems. But the interesting point is those correct solutions that Copilot generate, those 62% correct solutions that Copilot generate for this problem are optimal in 90 to 5% of the time. So it means that if Copilot, because also for this problem, it is very important, like you can solve this problem with different algorithms, with different complexity, with different like big O complexity. But Copilot could find and for each of this problem, there are like different algorithms with different complexity. But Copilot in those correct solution, most of the time suggest the optimal solution. And also like comparing these 2 trials together, Copilot was able to reproduce 86% of its correct solution like after a few days. Which gives us kind of like to see other competence of Copilot beside like solving a problem correctly, which is like maybe finding the optimal solution or like kind of reproduce the same solution in different run. For the second part of the study, which is comparing Copilot with human solution and in the quality and also effectiveness, we use a data set of Python programming course that the data set has luckily the student submissions also for the assignment of the course that the student submissions are in 2 categories, correct or even like buggy, and like the solutions which are not addressing purpose of the assignment. So we give the same descriptions that it was given to the students, to the Copilot, and we try it on, we try each problem in 5 different attempts, and we collect those top 10 suggestions by Copilot, because we have like lots of solutions for students to have a fair comparison. We downsample each time the student submission in the same size of the Copilot suggestion. But we didn't want to just check if Copilot can solve this problem correctly. One of the things that we were really interesting to check was like those buggy codes that are generated by Copilot and compare them with the buggy code of the students. So to do so, we use repairing tools named Refactory that actually based on the AST of the code, it finds that you should show some correct solution for the problems, and then it can find the blocks of the code based on the abstract syntax tree of the code, which is need to be replaced or removed to repair the bug. And the other interesting point about this tool is it reports 3 different interesting metrics. The first one is repairing rate, which is for example, if you have like 100 buggy code for the same problem, which are like different bugs, but for the same, they're addressing the same problem, how many % of those buggy code could be repaired? This is the repairing rate. And the other one is like the time which is need to the tool takes to repair the bugs. And the last one is the patch size, which is calculated based on the nodes that are added to the abstract syntax tree and removed from the tree to fix the bug. So our result shows, as we expected, students can solve these problems like more correctly than Copilot. So the correct ratio of Copilot for this problem. However, there are like simple problem for the like Python programming task, but the correct ratio of Copilot suggestions is less than student, and the student can solve this problem more accurately. But the interesting part was Copilot, the buggy code of Copilot could be repaired by this tool in 95% of the time. So 95% of the buggy codes generated by Copilot were able to be fixed. So even we checked the buggy codes manually, and we found that sometimes the bugs are generated by Copilot are very simple, such as, for example, instead of greater equal, it is using, for example, greater. And but this is not like the same for the student. The students buggy code, however, the problems, as I said, are like Python programming, learning like a course. But those bugs that are generated by the students are more difficult to be repaired, and even it takes more time for the tool to repair the bugs generated by students. To continue our investigation and comparing Copilot with human, one of the things that attracted our attention was whenever we were trying a prompt on Copilot, it was showing us that the suggested solutions are duplicates hidden. However, that was not what we were seeing. The Copilot suggestions are sometimes those top suggestions are exactly the same, and just like the variable name or the function names are the difference. And the reason that Copilot suggests them as non-duplicate solution is because to remove the duplicate solution, Copilot use the sequence of the tokens in a like different suggestion to detect the duplicates. So if, for example, the variable name change in the same function, or for example, you add a new comments to the code, Copilot consider it as a new suggestion. But what we were interesting to like search and like to find an answer for it is like for one single problem, really how diverse could be the correct solution of Copilot, like how different ways Copilots are taking to solve the same problems, and then we compare it like with human, with the students. And so for this reason, and we call it like the novelty of Copilots and students in solving problem. So to address that, we compare, actually to detect those duplication, we compare the AST of the codes, like pairwise, all the solution of Copilot for the same problem, and we did the same like for the students, and we drew up the last layer leaves of the tree, which is I can say that not just necessarily the last layer, but all those attributes that were assigned to the node name in Python programming compile. So by removing those variable names and like function names and comments, we were able to compare the exact like syntax of the codes together and detect like the real duplicates. So our result shows that Copilot can generate more diverse, students can generate more diverse and more like novel solution compared to Copilot. For example, in this specific problem, so just a brief explanation on the graph. The bar chart with crossed line are representing a student result, and the bar chart without a crossed line are representing the Copilots. And so, for example, and the bar chart showing the cumulative distribution of different type of solution, for example, which is correct and buggy. So as we can see, like for the correct solution, let's focus on the green part of the chart. In different attempts, this cumulative distribution for the correct solutions are increasing. However, for the Copilot, when we remove the duplicates within this like correct solution, there were lots of duplicates, and for example, in our fifth attempt, out of 28 correct solutions suggested by Copilot, there were only 2 unique solutions, and the rest of solutions were repeated. Were repeating these 2 solutions with different variable names or comments or descriptions. However, this is not the same story for a student. For example, in our fifth attempt, out of 22 correct solutions suggested by students, 21 of them were unique, and like the diversity is like greater than a Copilot solution. However, it is kind of expected because there are like different people that are solving, for example, the same problem, but in the other side, we are asking the same problem from the same tool, like again and again. But that was actually really make us like curious to know why a student, for example, generate this diverse, this much like diverse solution for a specific problem. So for example, this is 2 solutions generated by human and Copilot for the same problem. So our investigation shows that students sometimes generate codes that are not necessarily the best practice. So they are like not understandable, they are like complex. However, Copilot maybe keep repeating like the same solution, but it is like more understandable and like the better code, like compared to the student codes that which is like not very well readable. So that direct us to calculating the cyclomatic complexity of the solutions generated by Copilot and compare it with students for this different programming tasks. So our result shows that, as you can see, cyclomatic complexity of Copilot solution are less than students. So, however, they are not as diverse as the students, but those diversity in student solutions are not that like necessarily like. However, it is like we can solve a problem with our choice and in the way that we are going to write the code, but sometimes that diversity can cause like complexity and like make the code not non-understandable. So, however, the suggestion of Copilot are not very diverse, and sometimes for a specific problem, it can be just two different correct solution that is representing by different type of variables and function name, but they are less complex and more understandable. So when we were like doing all the experiments, we have also collect our experience of working with Copilot and kind of build a list of suggestion for you if you wanted to like use Copilot, how you can use it like more effectively. So, for example, one of the things is that Copilot really struggled to understand some natural language description, which was understandable by students. For example, in one of our assignments, the assignment asked to sort the list in a way that the older people stays at the front of the list, which that was understandable by a student and the student could handle it, but a Copilot couldn't understand the order of sorting for the numbers in the list. And actually in most of its solution it sort list in a different order. But when in another experiment we changed that description into ordering, actually sorting the list in descending order, which is more programming keyword. And the interesting part was the correct ratio of solution generated by Copilot increases from 40% to 79%. So if you are like going to write like prompts and ask Copilot to do something for you, that is like better if you could use, for example, more programming keyword. That make Copilot more responsive when you use more programming keyword. The other thing is you cannot tell Copilot to, for example, don't use something. You can tell it what to do, but you cannot tell it what not to do. So in one of our questions, in one of our assignment, students were asked to don't use sort and sorted, which are two built-in functions in Python. And students understand it and they didn't use it in their submissions, but that was not understandable for Copilot, and Copilot actually suggests majority of its solutions with by using the sorted and sorted functions. And the other part is like Copilot struggle in understanding long prompts. So if, for example, you ask for a different function in a single prompt, that may cause a Copilot a problem in understanding like implementing three different separate functions. So in one of our assignments, the students were asked to implement three different functions that name differently and do like has different functionality that the students could understand and apply it, but Copilot implement the whole problem in one single function. So in another experiment, we try to like separate those three functions into like three separate prompts and ask those prompts from Copilot separately. And the interesting part was the correct ratio from 0 increases to 44% for this specific assignment. And the other part is that Copilot, the other actually our finding is Copilot sometimes confused with the order of like argument in your function, or like the type of argument in your function that you were asking it to write it. So that would be really helpful if you can put an example of the expected like input that you are going to you are expecting your function to accept it. So we did it in one of our assignments. So we add actually an example of the type of input that we are going to give to the function and add it to the prompt, and it increases the correct ratio from 44% to 91%. So that are the tips that could be great to have in mind when you are working with Copilot and like practicing with it. But if you get back to our question that was like, okay, so using Copilot as an AI pair programmer and like replacing one of those pair by a Copilot, is it going to be an asset or a liability? So I can say that however Copilot generate optimal code and like codes that are easy to fix and understandable, and it can reproduce those correct solution like in different runs and in different even schedules. But it still generates wrong code and complex code, and it's always need like those solutions really need to be filtered by an expert or tool before being added to the software projects or open source project. I can say that maybe our experiment cannot be very conclusive to explicitly answer to that question and pick, for example, one of the things that like Copilot is an asset 100% or it's 100% a headache for the projects, but I can say that it could be, our assumption is that it could be really depends on the expertise of who is using Copilot as a pair programming tools. So our assumption is that maybe expert may filter, may be able, based on their knowledge, maybe filter out those bad practices. However, juniors may fully trust to these suggestions and like accept it, like even those buggy and like complex code. So that would be really interesting. So as a future direction, that we could like build some tools on top of Copilot that can filter this buggy or bad practices even before like showing them to the end user. So yeah, that was all about our study. Thank you for coming till here with us. And you can, if you want to like know more detail about our experiment, you can check our paper. I put the link of the paper in the description of the video, and we would be happy to hear your questions and comments. Thank you.